This lesson is let W be the subspace of span by U1, U2. Write Y as the sum of a vector in W and a vector orthogonal to W. So this is Y, this is U1, and this is U2. Now in this example, we're going to do pretty much the same thing from the last video. The only difference is that now I include the second part of orthogonal decomposition. So let's do number one first. Make sure that it is orthogonal. So here's U1, U2, just multiply 1 times 5 right here, plus 3 times 1 here, plus negative 2 times 4 here. And multiply, add, subtract across, and it does come out to be 0. Since it is 0, then it is orthogonal set. Next, we do the orthogonal decomposition theorem, and there are two parts. This is the first part, and this is the second part. The last video that I did, it only showed this part. So now we do both parts to complete the orthogonal decomposition theorem. Again, orthogonal decomposition theorem has two parts, this one and this one. Okay, so now we do YU1 over U1 U1 times U1 plus YU2 all over U2 U2 times U2. So here, let me scoot up a little bit. So Y1 and U1, Y times U1, so Y times U1, so 1 times 1 here, 3 times 3 here, 5 times negative 2 here, simplify gives me 0. Y times U2, so let's keep this in order. Y times U2, so YU2, so 1 times 5 is here. 3 times 1 is here. 5 times 4, which is here. Simplify gives me 28. Now U1, U1, so do this twice. 1 times 1 here. 3 times 3 here, negative 2 times negative 2. Simplify gives me 14. And finally, the last one, U2 and U2. So U2 twice, so 5 times 5 here, 1 times 1 here, 4 times 4 here. Simplify gives me 42. Now we all have the number to its variable, so we just plug them in. So Y, U1, 0, U1, U1, 14, sorry. So which is here. This is U1 plus Y, U2, which is this 28. And then U2, U2, which is here, 42. And this is U2. Now, this is 0. It's going to be 0 because 0 is on top. So the whole thing is 0. Multiply everything. It's just going to be 0. All I have left is just this part. So reduce 28 and 42 comes out to be 2/3. And then multiply across to every single of these terms. So 2/3 times 5 is 10/3. 2/3 times 1 is 2/3. 2/3 times 4 gives me 8/3. So this solution is Y hat. Y hat is the first part of orthogonal decomposition theorem. Okay, so this is the solution to Y hat that we are looking for. And Y hat is the first part of orthogonal decomposition. Now let's do the second part. The second part is Z equal Y minus Y hat. So we're just going to do Y minus Y hat. We already have Y, which is here. Y hat, we just found out. So Y minus Y hat. Y is this right here. Y hat is this right here. So we just subtract across. So 1 subtract 10/3, which is negative 7/3. 3 subtract 2/3 gives me 7/3. Okay. And then 5 subtract 8/3 is 7/3. Okay. So again, all we're going to do is for the second part is Y subtract Z. Y subtract Y hat will give me my Z. So Y subtract Y hat. So Y subtract Y hat. just subtract across, and this is the solution to z, which is the second part of what we are looking for in orthogonal decomposition. So one more time. Orthogonal decomposition theorem has two parts, this and this. So you have to do both, okay? And y hat is in W. So y hat is in W, and z is in W perpendicular. So this little symbol means perpendicular. So y hat is in W, and z is in W perpendicular. And y hat is in W. So instead of saying this, we can write it in this format: y hat equal projection W onto y. One more time. Y hat equal projection W to y. So instead of saying y hat is in W, we can rewrite it in this format. So later in other sections, if you see something like this, this means y hat is in W. And this is how we read it: y hat equal projection W to y. Okay, and z is in W perpendicular. So one more time, we need to make sure that it is orthogonal. So make sure that it is 0. When it comes to orthogonal decomposition theorem, make sure you do the first part and the second part. Okay, and then y hat is in W. We can rewrite it in this format: y hat equal projection W to y, and then z is in W perpendicular.